Thanks very much for coming out. Thanks for being online. And so I'm going to tell you, or try to tell you, every possible thing about our changing environment in 22 minutes. So I'm going to have to talk really fast. Actually, I'm not. What I'm hoping that you get out of this next 22 minutes or so is a whole lot of, that's interesting. I have some more questions. If that's where you're at 22 minutes from now, we'll know we're good. All right, so as Danielle said, I work at the University of Alaska Fairbanks, brought the 8th campus, traditional and never ceded lands of Lower Tanana Dene people. Very happy to be here in Dena'ina country as always. All right, so here's my little agenda for tonight. We're going to talk about our changing in climate, but how do we know what the climate is? What would we use to assess our changing environment? I'll be focusing to a limited extent on the greater Prince William Sound area, but I think it's really important to put what's happening in the region in a larger context. So we're going to be looking initially at a bunch of stuff kind of at the statewide or a little larger scale, but we'll zoom in on the Prince William Sound region. And we'll finish up with just a little bit on what the future may bring, but it's not going to be what you expect. You know what it's going to be. You don't need me to stand here and tell you it's going to be warmer and wetter. I'm going to focus on something you haven't talked about, the variability in the future, because that is critical to ecosystems, to human responses, to the way that we're going to live in the world in 20, 50, 100 years. All right, let's get the preliminaries right out of the way. Okay, weather. What's weather? Weather's the instantaneous state of the atmosphere. What you walk outside right now with your whole panoply of instruments, whatever you can measure right now, that's weather. We can also talk about the weather in the place in the day that you were born. We can talk about the weather at 2 o'clock on Christmas Day in 2062. That's weather, instantaneous. Statistics, my joy is any kind of statistic that we can make from weather, any kind. So that could be the high temperature today. You don't think of that as a climate statistic, but it actually is. If you walk outside right now, you don't get the high temperature today, you get the instantaneous temperature. We can talk about the long-term average. We can talk about the extremes. What's the warmest it's ever been in Anchorage on December 1st? That's a statistic. How often is there 2 feet of snow on the ground at Christmas in Valdez? That's a climate, that's a statistic of weather. So it's climate. So weather is instantaneous, climate is almost everything else. And lastly, and this comes up in all kinds of work, and we'll show an example of this later. It's almost never in the world of weather and climate a well-formed question to ask. Did La Nina cause yesterday's snow in Anchorage? It's not really a well-formed question. Did last winter's La Nina cause the coldest November of record in Bristol Bay? Not a well-formed question. Did last Christmas's rain in Fairbanks, was that caused by global warming? Not a well-formed question. Why? Because there is a multitude of pieces, multitude of things going on in the environment all at the same time. Sometimes we can parse those out, sometimes we can't. But this kind of question is almost never well-formed. All right, let's jump right in. Hopefully you can see this. This is a map. This is just from a couple days ago. I just pulled this up basically at random. This is a plot of basically every weather observation that was available in the greater Prince William Sound area here at 8 o'clock on Tuesday. We are living in the golden age of weather observation. There are hundreds of real-time weather observations available in the state of Alaska. I didn't count them, but I'll bet there's pushing 100 data points on just this little segment. These are owned and operated by many organizations, federal agencies, things you might think of, like various line offices in NOAA, like the Weather Service or the Ocean Service, the FAA, Natural Resources Conservation Service, USGS, State of Alaska, and even you. You may be one of those people that has your home weather station online, and it might be even plotted right here. This is, of course, very different than the situation 50 years ago, when virtually everything was a federally owned and operated asset, and there was way fewer. Now, golden age of weather observations all across Alaska. Climate observations is another story. Remember what we started out with, difference between weather and climate. The good news is for Prince William Sound region, climate is in pretty good shape. Not as great as we like, but far better than much of northern and western Alaska. Basically everywhere west of the road system, climate observations have collapsed in the last 25 years. We have less data today in western and northern Alaska than we did in 1950. Not the case in Prince William Sound. Again, I'm not sure if you can read this, but we've got this is the August total precipitation. So this is a statistic, it's climate. And we have, I don't know if you, so here's Valdez, here's Cordova, down here's Seward, here's Girdwood, here's Whittier. We've got a bunch of mostly automated, but still, I know this is a novel idea, actual human beings taking climate obs at a few of these sites. And that's, of course, is very important. But again, we here in Prince William Sound area, we're doing pretty good as far as climate observations compared to much of Alaska. What we lack in the Prince William Sound area are stable long-term sites. There's more or less no place with even 50 years of stable long-term records. Some sites, Seward, Valdez, Cordova, have observations going back to the pre-World War I era, but they're broken. Sites have moved around all over the place. It's really hard to use that from a rigorous scientific way. That's different than, of course, some other parts of the state. Not many, but we've got a lot of information on what's happening now, less of a continuous record. So how do we get around that? Welcome to, say hello to reanalysis. Hi. All right, what is reanalysis? Basically, it's been around for about 25 years, but only in the last couple of years has it gotten to the point where we can start to make credible statements about what's happening near the ground in reasonably small areas. So basically, all it is, you're running a weather model, but you're only running it for a few hours, and then you're going to start over. And then you're going to incorporate actual observations. So it's a weather model tweaked to some version of reality. Now, we run this same weather model, restart it every few hours. It provides us with the best estimate of what's happening over a continuous area, and many variables. Because it's a physical model, it's a weather model, so full physical variables. It's much more than just high temperatures or precipitation. All kinds of stuff, much of which can't be measured reliably at any scale, comes out of this. Now, the resolution right now is about 15 square miles for this, the best we have at the operational level from the European Center. 15 square miles sounds pretty good to, if you're in Oklahoma or Kansas or interior Alaska, that is pretty good. If you're in Prince William Sound, that's nowhere near good enough to capture the complex terrain. If you're in Southeast Alaska, think how the mountains come straight up out of the water in Juneau. So we're much better than we used to be. It's still not good enough for really mountainous terrain. It's the best we have. Invite me back in 10 years, I won't be showing you this. We'll have a whole new, look how great this one is. But but we're at the point where now this is usable. All right, Alaska's changing environment. Alaska is warming. I'm going to show you a bunch of these. I like to show 50-year trends. There's nothing magic about 50 years. It's the better part of an adult lifetime working memory. I can remember some weather events before 1972, but I can't put them into an adult context. So there's nothing magic about that. It's also a nice round number, right? Half century. Okay, temperatures are warming everywhere. It's warming a lot on the North Slope, down through into the northern Bering Sea. That's all sea ice change related. Prince William Sound area, also warming. Generally, over the last 50 years, it's warmed 2 to 4 degrees, average annual temperature. That's quite a change for a year-long temperature. It's not as large as on the North Slope, nowhere close, because of the influence of ice here. Alaska is mostly getting wetter, but not nearly as dramatic as temperatures. Big changes up on the slope here. Again, loss of sea ice driven. Open water, much longer period of time. Most of the state wetter, but this is that's the 5% is the first 5 to 15%, the first green shade there. So that's not very much change over 50 years. In the Prince William Sound area, it's actually mixed. Very weak changes here along the eastern Kenai Peninsula, maybe a little bit of increase Prince William Sound proper. All in all, it's pretty mixed and it's very weak signal. Oh, so precipitation's not changing that much. Well, that's at the annual scale, we could say that, but we'll be seeing some interesting things here momentarily. How about snow? Snow is critically important to Prince William Sound ecosystem. For the state as a whole, it's a whole lot of nothing. Very little change. Very little change. Except, basically, along the South Coast, you've got some downward trend, including the Prince William Sound area, but it's pretty weak. Increases on the North Slope. You already know why. Loss of sea ice. Go ahead, say it. Loss of sea ice. All right. Notice here in Southeast, this is where, especially the outer coast, this is where a really dramatic loss of snow, with much more precipitation coming as rain. And the oceans are warming. What a surprise. Again, big changes, ice affected areas. But even in the deep water of the Gulf of Alaska, everybody's warming in a fairly large chunk. The August average has warmed about 1.5 degrees Celsius in the last 50 years. That doesn't sound like very much, but how dense is water compared to air? That is a lot of extra heat in the water. That's a lot. Even in the deep part of the, oops. Okay, now we did it. Okay, so that's it. Even in the deep part of the Bering Sea, it's warming. Okay, you already seen this. Long-term changes in ocean temperatures and surface temperatures in the Gulf of Alaska since 1900. The way you might know, I like to do these. The blue dots are the 10 coldest years. The red dots are the 10 warmest years. You don't need any statistical analysis to see. Up, 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 and 8 of the 10 warmest years have been in the last 25, and more than 6 of 10 have been since 2013. The blob years are in here too. Long-term change, very dramatic. What's the difference in heat content between an average warm season temperature of 9 C versus 11 plus C? Tremendous amount of heat. All right, we've been looking at kind of longer term change, but one of the big things that I want to stress is changing seasonality. This should be one of the moments. This is a change in the summer precipitation. Again, 50 years. Look how much wetter it is, basically from Prince William Sound eastward. It has really gotten a lot. These are big numbers here. This is in excess of basically 50% increase in 50 years. That is stunning, isn't it? But look what's happening back here. So lower Alaska Peninsula, eastern Aleutians, fairly substantial drying. This suggests to me, putting on my meteorologist hat, This looks like there's a significant shift in the storm track in the summer. You know what this is up here. This looks like something else. This is sea ice loss. This looks like a storm track change. Differing processes happening all at the same time. But if we look at changes in seasonal snow, remember, for the whole season, not much change. But look at this. Almost everywhere in Alaska has much less autumn snow now. But away from the coast, most of mainland Alaska has much more snow in midwinter. At the moment, they're basically balancing out. But that change in seasonality is important for all kinds of processes. It's important for all kinds of human activities. So it isn't enough to say, oh, snow's not changing much. We're getting about the same amount of snow as we used to get. Over much of the state, we're getting more in midwinter, less early in the season. Big changes to how ecosystems and people respond to that. All right, last year, there's a problem in Valdez with snow, as you all know. Luckily, NRCS has run a couple of snow courses, actually 3 in the greater Valdez area for a while. This is the one on Sugarloaf Mountain above the terminal. Since 1985, although they missed a bunch of years here, this is the April 1st snowpack, so the water in the snow. And yeah, last year was the highest in 10 years, but obviously was not particularly impressive by 1980s and 90s standards. In this time here, 24% decrease just in the modeled average here. I've estimated here the missing data from the 2 other snow courses in the Valdez area. But we don't have to estimate. The Valdez snow course actually has 51 years of data now. That's almost getting up there to make me happy. And you can see, even when we add on another 13 years of data from that Sugarloaf, there's still a downward trend. It's not as strong, but the end of season snowpack is decreasing. These are, for those of the statistical bent, these are statistically significant trends. All right, to wrap it up, I'm not going to warp it up, just going to wrap it up. Happily, our organizers caught that this had been warped. So thank you. All right, like I said, you don't need me to tell you the future is going to be warmer. You know that. How warm it's going to be depends on what human society does. We know exactly why. How much it's going to warm depends on what we as a species, as societies, do. I'm being optimistic here. I've used a RCP scenario, so a future projection of 4.5. That's a pretty aggressive mitigation scenario. And the green line is what you would read. Oh, this is how much the temperature is going to increase. I pulled this off of the, this is for where? Western Prince William Sound here. But what I want to call your attention to are the dots here. What I've done is I've taken this average and I've said, there's no reason to think we won't have the same amount of year-to-year variability that we've had historically. So these are not forecasts for these years. This is the average, and I've just superimposed this variability on these. We have years out through mid-century that we have years out through mid-century that would be not particularly impressive today, even in this fairly sharp warming. And even into the later 21st century, we still get occasional years that are pretty cold. We also will get years that are far outside of anything we've seen heretofore. But this variability isn't going away. And this is really important to understand for planning, for understanding ecosystem response, for understanding and planning for human response to our changing environment. It isn't that every year is going to be a little bit warmer than the year before. The variability doesn't go away. Same with precipitation. Precipitation is forecast to increase in all of Alaska, but not as dramatically as temperature. It's exactly what we've seen so far, right? Again, here, this is the greater Prince William Sound area. I think I actually used Tutitlik here for the projection. And total annual precipitation increases. There's still plenty of dry years. There's dry years through mid-century that would be dry in the historical record. Again, assuming the standard, the same variability that we have had in the past holds on. We also get years that are far wetter than anything we've seen, at least in the last 50 years. So variability is our friend. Now, I don't have a graphic for you because we don't have good projections for it. Snow levels, of course, are going to continue to rise. Sea level snowpacks overall will continue to decline. At some elevation, pretty high, snow will, of course, increase because you're getting more precipitation, but snow levels will be rising at the same time. So that is the entirety of what I have for you. I hope I got you to say, if you haven't seen our Alaska's Changing Environment from International Arctic Research Center, it's on our website. It's a great science communications tool that I'm very proud of. And so go check it out. So thanks a lot. Questions?
Hi, this is Tom Cooker. I was looking at your average temperature increase or variability in the first slide you put up there. And it appeared like the Russians are doing much better with respect to their temperature control there. And I'm wondering if you have any comment on that as to why that might be. Yeah, right there.
This one?
Yeah.
Oh, this is just 1 month. This was just October.
Oh, okay.
This is just to illustrate reanalysis. So yeah, October was cold over Chukotka here.
All right. Just kind of striking.
Here's the 50-year change. They're doing as well as or bad as we are.
All right. Thank you.
Good spot though.
Hi, Roger Green. I'm on SAC. Have been since '03. I particularly liked your point about the importance of having sites with really long-term, continuous, consistent records and the difference it makes if you don't, because that's the subject of a talk that I with Danielle gave at an oil spill conference in Halifax shortly ago, pointing out, of course, how good we are on LTEMP in the monitoring by having consistent things, but that's a very important point.
Are there any questions online?
So I remember in '65, Cook Inlet was froze over. It was cold. I'm surprised I can still remember back to that, but I can because we were stuck in that ice. But at any rate, we haven't seen that in a while. I guess my question is, you know, you dealing with this kind of stuff and with the rate of carbon dioxide and the pollution that is in the atmosphere, what is a reasonable expectation to how high the temperature could get? And is it something that is going to be totally detrimental to a human being?
So are we talking the weather scale or climate scale, or how hot could Death Valley get? How hot could the Arabian Peninsula
Well,
get?
this is
Or-
true. We have various places that are up to 120, probably close to 130 degrees as it is now, but that's the extremes in the desert. But say in a municipal area like Los Angeles or a big city.
Well, certainly we are seeing places in the Middle East that are on the water, the Gulf of Oman, the Red Sea, where the waters are so warm that the moisture in the air, technically the dew point, is at times at or above the normal human body temperature, skin temperature, which means that the human body can't cool through sweating.
Right.
Those become effectively impossible to live in without artificial environment control. Right now, that's very confined to a few areas. Temperatures are going up, water temperatures, ocean temperatures are going to continue to rise for longer than anyone in this room will be alive. We will see more of that. That kind of unable to sustain human life will be confined to small areas, but it will increase.
Yeah. Scary thoughts. Just one last thought, volcanism and ash. A significant change in the temperature pattern of the world.
If we get a good volcano to pop off at the right place is typically low latitude, where the ash can spread out the most. Sure, we could get a big dip for a year or two. Pinatubo is when was Pinatubo? 91, 92. That was the last big one, big enough in an equatorial area, cooled the global temperature quite dramatically. It would take a tempura level 75,000 year eruption to cool the atmosphere for longer than a year or two. Regionally, of course, they can have effects, but if we're banking on volcanism to save us, I think there's some a bitcom for you.
Thanks for the good talk. You threw out a piece of bait and I took it. Talk about those storm track changes over by Yakutat, because that intrigues me, because we got the barrier jets and we got shipping going through that area. So that has implications for the shippers.
Right. So this is I think this is stunning for a whole bunch of reasons, because there's no reason in the global warming signal, there's no reason to think it would produce a pattern like this. This is clearly a environmental warming, a climate warming signal. This is not. This is pointing to something else. And drying in the Aleutians, Alaska Peninsula, wetting in Southeast Alaska, the Eastern Gulf, that's got storm track written all over it. What that means for your purposes is that there's no particular reason to think that this won't shift back. Which decade that will be? Don't know. But there's no reason, if we had, come back in 50 years, okay, now we've got 100 years of this. This probably will not look like this for the summer. This will be much more smoothed out as the storm track meanders around, so in individual decades, favoring the Aleutians or the Eastern Gulf. But at a 100-year record, this would be much smoother. I'm almost sure of it. In 100 years, this will be even more pronounced. Make sense?
Hi, Rick. Thanks for coming down. I just wonder if there's been any tie-in or any work with oceanographers on the Japanese current or on the East Coast as far as the Gulf Stream, and how this will impact future circulation patterns there too.
So, of course, there's been an immense amount of work on what melting Greenland ice sheet will do in the North Atlantic and affecting the Gulf Stream. Will that result in shutting that down or significantly diverting it? There's been less work at the climate scale on the currents in the North Pacific. Obviously, there's some work, there's a lot of interest and been considerable work, for instance, in how increased freshwater runoff from the Alaska and to some extent British Columbia coast are affecting currents in the Gulf of Alaska. But across the open North Pacific, there's been much less work that I'm aware of on the climate scale, the multi-decade scale changes. So anybody want a PhD project? All right, great. Thank you very much.